Okay, we are on page 10. Okay, definition of limit. We talked about this in chapter 1, where limit is, for example, something like this. Limit as x goes to a, f of x equals to L. What that means is when x is trying to get to a, y is trying to get to L. Okay, so when x is getting arbitrarily close but not equal to a, f of x is trying to get to L. Okay, so the key is not at a, just trying to get to a. Okay, trying to get to a. All right, so let's look at the limit of the following graphs. So let's look at this one. Limit as x goes to 3 of 2x minus 1. As x is going to 3, what does y look like it's going to?
5.
This is like the VIPC that always shouts out answers. Okay, thank you. 5. Okay, you guys can see that? When x is trying to go to 3, y is trying to go to 5. Yes? Now, this one is very easy where you can just plug in. Okay, when x is going to 3, so it's just 2 times 3 minus 1, so that is 5. First step in finding limit, just plug it in. Most of the time, you can just get the answer without doing much work. Next one. When limit as x goes to infinity of x squared plus 3. When x is going to infinity, where is y going to?
Positive infinity.
Positive infinity. So when x is trying to go to infinity, y is going all the way up, so that is infinity. All right, next one. Limit as n goes to infinity of 1 over n. When n is going to infinity, that is the x part. Where is y going to?
0.
0. Yes. Okay, so you can see that when n is going to infinity, y is going down. So it's going to go to 0. All right. Now let's look at this question. Find the limit of this. Okay, so it might be a little hard to figure out what it looks like. You may want to plug it in, but maybe you want to graph it. So talk to your partner. You guys decide what the limit is. Let's start with Edward. What do you think? Huh? 2? Okay. Murphy? 3? Sophie and Philip? 1? Okay, Jingyi and Jingzi? 3? Okay, 2 votes. Cielo? 3 votes. Okay.
3.
3? Elizabeth and Cami?
We said 9 because there's a hole in that.
Okay, so undefined?
Yeah.
Okay, Gary? 3? Bruno and Lisa? Undefined? Okay. Sunny and Peter? Undefined? Okay, so I think this one has 3 people. Okay, Wimbo and Jim?
Less than 3.
Less than 3.
We changed to undefined.
You changed to undefined. You had a 3 before?
Yeah.
Cross it out.
No, hold on. I'll keep 3 and you change to undefined.
Yes.
We are right anyway.
Yeah.
Okay. All right. Raymond Kim. 1? All right. The answer is 3. Why?
Why?
Why is it 3? All right. Let's look at this graph. Okay. This graph, it looks, I don't remember how the graph looks like. You guys have the graph?
It's just like x squared.
Okay. Looks like this. The question is, when x is going to 1, where is y going to? Remember, the key is arbitrarily close, but not equal to. When x is trying to get to 1, where is y trying to get to, but not equal to? 3. Okay, when x is going to 1, y is trying to get to 3. It's just not going to equal 3. But it's close to 3, correct. So that's what limit means. It's close to 3. Now, how are you going to find this? Can you guys Focus. Okay, so how are you going to figure this out algebraically? Well, let's try it as it is. Okay, so limit as x goes to 1 of x cubed minus 1 over x minus 1. What happens if I put in 1 right now? Undefined. Oh, actually, we don't call this undefined, but next year you'll... Indeterminate. Indeterminate. Okay, so we don't know. That means we don't know. Okay, this year, don't worry about it. Next year, you have to write indeterminate. So we don't know. 0 over 0 is we don't know. So what we're going to do is we're going to be a little bit clever and say, what can I do with this x cubed minus 1?
You can separate the two.
Yeah, we can factor. And how do we factor that?
X minus 1
X squared plus
Plus
minus
x plus 1. Good. Okay, so same, opposite, always positive. All right, over x minus 1. And then just a little calculus note. You have to keep the limit sign the whole time. You cannot get rid of it. If you do, then next year on the AP test, you'll get a lot of points off. So you got to keep that limit sign the whole time. Okay, that cancels. So limit as x goes to 1 is that function becomes x squared plus x plus 1. And at this time, you can just substitute. So it's 1 plus 1 plus 1, 3. So when x is going to 1, y is trying to go to 3. Okay, now, sorry, let me finish.
Okay.
Now, you don't want to use this trick every single time because sometimes you get lucky by plugging it in, you'll get the answer. Right? So the first step you should do when you see a limit problem is always just plug in. When you see that it doesn't work, then factor or do something. But don't just try to factor first because you may be wasting your time. You have a question?
Even on your work on the AP test, like, you have to keep the...
Yes. Yes.
Well, that's the problem.
Yeah, you have to.
Jump in there.
Well, I'm going to drill you next year so you don't make this kind of mistake.
I'm so bad with that.
Okay. All right, so let's have you guys try 1 and 2 on your own. Let me know when you're done. So number 1, the answer is -1/4. Number 2 is 3 over 5. Okay, now let's look at some limit rules. First rule, sum rule. These rules are very easy because it's very intuitive. If you are trying to find the limit of some function plus some function and you're like, it's really hard to figure out the limit when I combine them together, you can take the limit of each function separately. Once you find the limit, add them together. So what that means is if you see something like this, you can just write it as limit as x goes to c of f of x plus limit as x goes to c of g of x. Just find the limit individually and then add them together because it's easier that way sometimes. Okay, when you are trying to take the limit of two functions that's subtracting each other, same thing. You can take the limit of each one individually and then subtract them. Okay, same thing with multiply. Multiplying limits, you can take the limit of each part separately and then multiply them together. So the limit as x goes to c of f of x times limit as x goes to c of g of x. So these are very intuitive things that you probably would think about doing anyways. Next, constant multiple. So if you have a constant k multiplied by a function, you can take that k out so you don't evaluate it with the limit. And then that would still be the same answer. If you have a limit of a quotient, same thing. So limit as x goes to c of f of x divided by limit as x goes to c of g of x. Obviously, that's if the bottom limit doesn't go to 0. If it goes to 0, it is undefined. All right, so far so good. Very easy stuff. Okay, next. if you have a limit of some function to a power, you can take that power outside so it's easier to evaluate. So you can do limit as x goes to c of f of x, and then the whole thing to that power. All right, last one. If you have the limit of a root, you can take that root outside as well. And then put the limit inside. All right, that's if that root is greater than 2. And then all those numbers are real numbers, meaning like there's no imaginary, you're not taking a root of a imaginary number. All right, let's use these rules. For example, use the fact that limit as x goes to 0 of sine x over x is 1. Find the following limits. Okay, so there's this fact that we need to use. The fact is limit as x goes to 0 of sine x over x is 1. How do we solve this problem? This problem is very complicated. If you do put in 0 right now, you're going to have a 0 plus 0 over 0. So that's not going to work. So the key is, how do we somehow switch this problem, the really weird, complicated problem, into something that has this part so that we can use this fact that we already know? Raise your hand. Yes, Elizabeth.
Can't you just like the original equation, like figure it out, like, you know how it said you divide it, so like limit of x goes to 0 sine x and then divided by.
Yes, we can, but it's not going to help us because if we split it into two quotients, limit as
the first one, and then figure out the first one.
this one,
No.
this one,
Yeah.
but they already told us it's 1.
Yeah, but you can figure out like what sine x is as it goes to 0.
How are you going to figure that out?
Or like, no.
It's going to be 0 over 0. Thoughts? Yes. Separate, how? Yes. So somehow we need to get it to look like a sine x over x so that we can use it, right? So we can just say this is x over x plus sine x over x, right? Okay, x over x is what? 1. Okay, so this is the limit as x goes to 0 of 1 plus sine x over x. Now, what kind of limit rule am I going to apply to be able to solve this?
1.
Yes, the addition rule. So this is the limit as x goes to 0 of 1 plus the limit as x goes to 0 of sine x over x. All right, so we're going to evaluate each function separately. First one, the limit as x goes to 0 of 1. F of x is 1, meaning it's a flat line. So when x is 0, what is y? 1. So then that limit is just 1. Plus, and limit as x goes to 0 of sine x over x is 1. So then this is 2. All right, let's verify in decimals. So you can graph in decimals or I'll show you in decimals. All right, how about this one? There is no sine x available on this question. How are we going to use some trick? Yes, we're going to have to recall our trick stuff. Pythagorean identity. So 1 minus cosine squared is sine squared. So this is sine squared x over x squared. If we plug in, yeah, that's correct. But if we plug in 0 right now, it's just 0 over 0. So it's not going to work. So which limit rule are we going to use?
Division.
No, division is still going to get 0 over 0.
Root.
Huh? Not root. Power rule. Okay, power rule. So this is limit as x goes to 0 of sine x over x, the whole thing squared. Okay, you cannot just all of a sudden get to 1. I know the answer is 1, and you can probably see that it's 1. The problem is that you have to prove that you have this procedure of getting there. If you just say 1, you're basically telling people you just plug it in 0, but 0 over 0 is not 1. So you couldn't really get there. You have to apply your limit rules. Okay, so at this point, it's 1 squared, so it's 1. Are you guys good? Okay, so let's have you try the last one. Please just make sure you applied your limit rules. So some of you did it this way, which I think is a good, example to show like what you may do that's not gonna solve the problem correctly. If you did this, remember you have to solve it. So limit as x goes to 0 of cube root of sine x means you just plug in 0. What do you get when you plug in 0? In there. Sine of 0 is what? 0. Cube root of 0 is 0. So this is going to give you 0. And then this part is going to give you what? 0. So then you end up with 0 over 0. So it's still unsolvable. So you actually don't want to split it. Okay? And then also because the fact that they give you is sine x over x, not split. So this is not going to help you get the answer. You have to do this. Okay, so this is 1. Good, easy. All right, next. The crazy functions. What are we gonna do? Wow. Well, before, remember I said before you do any crazy things you wanna try, plug it in. You might get lucky and you don't have to do any work. So let's try it. E to the 0 minus tangent 0 over cosine squared 0. E to the 0 is what?
1.
Tangent 0. Hopefully you kind of remember. 0. Cosine 0 squared. 1. So the answer is 1. You didn't have to do any crazy stuff. Okay? So first thing, always plug it in. You might get lucky and you don't have to do any extra work. All right? Okay, try another one. Limit as n goes to 16 of this whole thing. Okay? Plug in 16. You may get lucky. Okay, square root 16 is 4. Log base 2 of 16. 4. So the answer is 1. Good. All right, let's have you guys try number 3 on your own. Okay, so number 3, you're going to plug in 1/2. You're going to get natural log 2 times 1/2, so that's 1, plus cosine of pi over 2, 1/2 minus sine of pi over 2. Okay, natural log 1 is 0. Cosine of 1/2 is 0. I'm sorry, why did I write 1? Plus 0 over sine of pi over 2 is 1, so that's a negative 1/2. So the answer is 0. Okay? All right. Next, one-sided versus two-sided limits. Okay, so we talked about this again in chapter 1 where we had to go to an asymptote from the left hand to right. It's the same thing. So the limit as x goes to c minus. Minus means the left-hand side. So we're coming from the left-hand side. The question is, where is y going to? Okay, so the limit as f of x approaches c from the negative side. Okay, when you see a minus, that's telling you we're coming from the left-hand side or the negative side of that number. And then we're trying to see where y is going to. Okay, so the next one, when x is going to c positive, positive means from the positive side. So we're coming to c from the positive side and saying, where is y going to? Okay, so this is from the positive side. All right, next part is very important part. A function f of x has a limit as x approaches c. If and only if. Okay, if and only if in math is a very, very important thing. It means unless this happens, it will not work. So that's why they put, it's not if this happens, it's if and only if. So if and only if is very important. If and only if the right-hand side and left-hand side limit as c something and r something. Okay, so what it's saying is the limit as x goes to c, just c, not minus, not plus, just c. This will exist only if, first, the left-hand side and right-hand side has a limit. So there is the first thing, it has to exist. Both sides are going to some number. Okay, first thing, it has to go to some number. Next, and then they have to equal. So there are two parts. This means limit as x goes to c of f of x exists if and only if. They write it like this. IFF means if and only if. Two things. First, limit as x goes to c minus and limit as x goes to c positive. They both exist. What does it mean when it doesn't exist?
No limit.
Low limit, how does that look like?
It goes on forever.
Yes, it goes on forever. So if it goes up or it goes down forever, that is not a limit because that's infinity. Infinity is not a number. It has to be an actual number. Okay, left-hand side, right-hand side has to go to an actual number. Yeah? Correct. Correct.
What'd she say?
She's saying that if someone writes limit as x goes to c, positive, that doesn't automatically mean there is a limit.
Okay.
Yeah, you have to actually tell them what it is. Okay, so left-hand side, right-hand side have to go to some number. Cannot shoot up or down. Okay, that's the first part. It has to exist. Second part, limit as x goes to c minus has to equal limit as x goes to c positive. And when they are equal, then there is a limit. Okay, left-hand side, right-hand side, first have to go to some number. Second, they have to equal. If they equal, then the limit is that number, that same number.
Explain that again, but after I finish it. Sorry. Okay.
All right, so the limit at a number, x equals a number, exists only if two things. First, left-hand side, right-hand side of that number goes to some y value.
Okay.
Second, they have to go to the same y value. If they go to the same y value, that number is the limit.
Oh, okay, I get it.
It's a straight line.
It's like it meets.
Yeah.
Yeah, okay.
What does it mean when both sides are not going to the same number? What does
like
it?
crossing it out. Pass out. It does not connect.
Yes, what is it called in math?
Discontinuous.
Yes, discontinuous. So that's pretty obvious, right? Left-hand side, right-hand side don't go to the same number. It's disconnected. So it's discontinuous. Yeah, like a jump. All right, the last thing we're going to do is I am going to let you guys do some whiteboard activity with some very interesting limit. This is going to be very interesting. This is getting into real calculus now.
What we're doing isn't real calculus?
It's like superficial. Very, very beginning. All right, so I'm going to show you these graphs.
Are we done with the eyebrow?
Yeah, we're done with the notes.
I know.
No.
Alrighty, this is a very strange graph. I'm gonna ask you some questions. See if you guys can figure it out. This is the fun stuff.
I don't think so.
All right, let's start with easy one. And please don't estimate and say like, that number is about 2.5. Okay, I'm not trying to get crazy there. All the numbers are integers.
Okay.
I know it's not perfect, but just think of them as integers. Limit as x goes to 1, negative of f of x. What is this limit? Okay, give me your answer. Write it on the whiteboard. Nope. That's correct.
Which one is f? The whole thing is f of x.
The whole thing is f.
Oh, it's negative.
Yes.
Oh.
No.
Okay.
Yes. Yes.
Which is that one?
Yes. No, not the number is right, but the way you write it is no good.
That's 1 meter. That's 1 meter.
No. No. Yes.
The negative
Yes.
side?
No.
Negative on the negative
Yes.
side, not both.
No. Yes, Lisa, you're right.
It goes
No.
from negative to 1.
Why is 2?
Yeah.
Let's talk about it. Yes. Yes.
One.
Okay. Why is it 2? When x is going to 1 from the negative side of this function, so we're going to 1 from 1 is here. From the negative side, we're going to follow this graph, not this one.
Oh.
Okay, from this graph, so we're going to stop at 2. So the limit is 2. Yes? At 1, it doesn't exist. 1 negative exists. At the actual value 1, it doesn't exist because they're not the same. But from the left-hand side, yeah. All right, next. Let's try another easy one. 2 positive. Okay, good. No. Yes, yes. No. Yes, 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 yes. Yes. No. Yes, yes. Yes. All right, the answer is 3. Okay, so going to 2 from the positive side, we're going to 3. All right? Okay, next. Let's try this. Limit as x goes to 3. No. Yes. Yes. No. No. Yes. No. Yes. Not a good idea. Yes, that's the perfect answer. No. 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 Yes. Yes. Okay. 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 Not the best answer. No.
Why is cannot be very
All right, what is going on at 3? Okay, limit as x goes to 3 exists if and only if 2 things. Left and right are going to some number. Does that happen?
No.
Yeah, they are going to some number, right? Oh, Sunny, wake up. Okay. Next, are they going to the same number?
No.
No, so then what does this mean? Does not exist is the perfect answer. Undefined, acceptable, not the best. Okay, does not exist. The limit does not exist. Okay, they have to exist somewhere. They have to go to the same number. Okay, does not exist. All right, try. Oh, I know. We're gonna get into interesting ones now.
This is interesting.
Oh, this is gonna get more interesting. F of 3.
Oh. This. Oh boy. That's a.
No.
No.
Yes. No.
Oh.
No. Where'd you get 2? Yes. 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 Yes.
Oh, okay.
F of 3.
Wrong.
Yeah? Yes. Yes. Okay. 4. Yes, correct. 4. 1, 3. The only part that exists is 4. Okay? So f of 3 just means where is the actual point at 3 that is only 4. Limit, there is a hole there, so it doesn't work. All right, let's try another one. Ooh. This will be fun. Okay. Limit as x goes to 1 of f of x plus limit as x goes to 2 of f of x. What are you gonna do? No. No. Yes. What? That makes no sense. No, no. Yes. No. That doesn't make sense. Yes. No. No. Yes. Yes. Okay. Okay. Yeah. No. All right. Let's look at it. Oh, Sunny, you gotta wake up. You're still all right. First, limit as x goes to 1 of f of x.
Doesn't exist.
Does not exist, right? We said left and right are not going to the same number, so it doesn't exist. Now, then what is this number?
3.
3. Does not exist plus 3.
It's 3.
Still does
No.
not exist. You can't add something that doesn't exist with a 3 and then say it now exists, right?
Yeah, but you cannot 3 plus something doesn't exist. It's still 3.
No. No. Does not exist. Does not exist. All right. Okay. Now we're gonna get into really fun stuff. I am gonna add another graph.
Oh. Pick a different one?
Yes. All right, this is called G. This is G. All right. Let's write this on the side. Maybe in a black color. Okay, limit as x goes to 1 minus of f of x plus g of x. Don't tell everybody, just write your answer. Yes. Yes. No. Yes. 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 No. No. Yes. No. No. No.
Yep.
Yes. No. You're just putting up random numbers now.
Yes.
All right, let's use our limit rules. Limit rule says we are going to, find the limit of each one separately, right? Okay, so the limit as x goes to 1 negative is 2. And then limit as x goes to 1 negative is 3. So 2 plus 3 is 5. So it's going to 5. All right? Okay. Oh, Daniel's doing a little dance now. Okay, let's do another one. Limit as x goes to, what should we do? 3 positive of g of x over f of x.
Oh, no.
Yes, yes, no. No.
I can't tell.
Yes, yes.
Okay, that is it.
No. Yes. Okay, good. Lisa, you're good. This is like a magic eye, huh? Yes. 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 Yes.
Oh my gosh.
No. Oh, okay, yeah. What? Where do you get that number?
Oh my gosh, G's on top of okay.
No. Wimble, no. Okay, the answer is 1/2. 1/2. G is going to 2, F is going to 4, so 2/4. All right, let's do 1.
2.5.
I said everything as an integer. Okay, limit, okay, last one. Limit x goes to, what's a weird one? Negative infinity? Let's do, I don't feel like I can trick you guys anymore. Oh, I know. F of 1 plus limit as x goes to 2 of g of x. Write your answer. Write something. Yes. Yes, yes, no. Yes, 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 yes. Not the best answer. The answer is does not exist. If you write infinity, it's okay. It's just not the best. Yeah, because you can see both sides are gonna go like that, right? So it does not exist. You can't say it's up or down.
It's fine.